Hi everyone, today we'll be doing some more work with ratios. We'll be finding ratios of parts to wholes. Our learning target for today is I can use unit fractions, remember that those are the ones with a 1 on the top, percents and ratios to find the part of a whole set or to find the whole. So let's imagine a situation. Let's say that there are 20 students in Mrs. Piper's class. 3 out of every 5 students are girls. How many students are girls? So here, what we know is the whole, that's 20 students, and we know the ratio. So I might take and make a model for this problem. So I'm going to make 3 out of 5 be girls. So I'm going to use the pink to represent girls and blue to represent boys. Whoops. So I'm going to make groups of 5. I'm going to make 3 girls and then 2 boys. Okay, I'm going to do this all the way until I get to 20. So I ran out of space a little bit, so let me make it a little bit smaller for you. I'm going to do this all the way until I get to 20. So now from here what I can do is I can count how many girls I have. Okay, so I'm going to show you, I'm going to use my pointer here and I'm going to count. So I've got 20 students all together and then all of the pink represent the girls. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I can say I have 12 girls. I could also say that I have 12 girls out of 20 students altogether. You'll notice that 12 out of 20 is the same ratio that we started with. We started with the ratio of 3 girls to every 5 students. And we can use a quick multiplication to check this. 3 times 4 is 12, and 5 times 4 is 20. Okay, there's a few different ways that we can think about ratios when we know either the part or the whole, or whether it's in simplest form or not. So I'm going to teach you each of these 3 ways, and then we can figure out any piece of that we don't know. So the first one that I'll give you is a ratio that's given in simplest form when we know the whole but we don't know the part. So the situation that I'm going to give you to think about is if we have a ratio of 1 pink tile to every 3 tiles. Okay, so we know the ratio, and that's a 1 to 3 ratio. And let's say that we have 15 tiles altogether. So what we need to figure out here is how many are pink. Okay, so that's our unknown. So what I'm going to do to try to solve this problem is make 1 out of every 3 pink. So I'm going to make 1 out of 3 is pink. Okay, and I'm going to do this until I get 15 tiles. Okay, so now I have 15 tiles laid out here, and then all I have to do is count how many pink ones I have. 1, 2, 3, 4, 5. So I'm going to fill in that I have 5 pink for every 15. And you'll notice here that these 2 ratios are equal, and they have to be. They're equivalent ratios. 1 to 3 is equal to 5 to 15. Another way that we might solve a problem is if the ratio is given in simplest form, if the part is known but the whole is unknown. So a situation for this might be a ratio of 1 pink tile to every 7 tiles, and then we have say 5 pink tiles, but we don't know how many there are altogether. Okay, so I'm going to show you how to model that one. So how I'm going to go about setting up this problem is I'm going to lay out 5 pink tiles. So 1, 2, 3, 4, 5. I don't need that one. And then I'm going to make this ratio so that 1 out of 7 is pink. So I'm going to add blue until I get a ratio of 1 out of 7. So now I have 7 tiles shown there. And I'll do this with each set until I have all the sets filled up. Okay, now I've got all the sets filled up. So what I want to see here is how many tiles do I have all together. So I can count, and I'm just going to count in groups of 7. So I have one group of 7, so 7, 14, 21, 28, 35. So all together, I have 35. So 1 to 7 is equal to 5 to 35. That's my check, and I always want to make sure I do that last part. Okay, here's our last situation. Sometimes we know the part and we know the whole, but we have a ratio that's not given in simplest form. So let's take a situation where we maybe have a whole of 35, and the ratio is 4 to 10. So what might 4 pink tiles for every 10 tiles look like if we had 35 tiles? So I'm going to show you what that would look like. So here I've set up a 4 to 10 ratio. I have 4 pink tiles for 10 tiles altogether. And I got myself to 30 tiles, and I'm not really sure what I should do with the rest. So you can see we've got 10, 20, 30 tiles. But now what we need to do is we need to come up with the same ratio, but we need to have only 5 more tiles to get us to 35. So I think I want to change the way that I'm looking at this a little bit. So I'm actually going to rearrange this so that I can have some piles of 5. So what I'm doing is I'm just rearranging the same exact tiles that I have. I haven't changed them at all. And I'm making them into 5, groups of 5. So do you see what this ratio is going to change into and look like? If you figured out that the ratio here is an equivalent to 4 out of 10, which is actually 2 out of 5, that can help us solve this problem. So it's really a 2 out of 5 ratio. So what I need to do now is add another 2 pink for a total of 5. So now I can figure out the part. So if I have 35 altogether, I just need to count the pink. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So I have 14 pink out of 35 altogether. A simpler way to do this, if you recognize that this is not in its simplest form, is to actually reduce that first and then go ahead and try to solve the problem the way that you've learned how.